our semifinals term, we will officially begin discussing another chapter of a lesson. So, since ang focus sa course organic chemistry is all about the carbon element itself, knowing na, di ba, we tackle here different organic compounds. So, yung main heart ng organic chem is carbon. So, it is also important for you to identify, to know the different or important properties of carbon itself. Although some of the important properties of carbon were already discussed in the previous discussions or lessons, let me run through those important properties of carbon. So let's start with stability. Okay. So ang carbon atom, it is considered to be highly stable. Take note ha, it is highly stable and its stability is related to what we call octet rule. Okay, again, its stability is related to octet rule, wherein there are about 8 electrons, valence electrons surrounding the atom carbon, and that 8 electrons is being shared by 4 covalent bonds. Okay, so always good na. Ang carbon may have may be surrounded with 4 single bonds, or it may carry 1 double bond, then the 2 are single bonds, so that is still 4 covalent bonds, or pwede rin yung central carbon may carry 2 double bonds, so 4 pa rin yan, 4 covalent bonds, or it may carry 1 triple bond and yung isa is a single bond. So total of 4 covalent bonds. That is the most stable number of bonds surrounding a carbon element. That makes it stable. Alright, so that's the first property of carbon. The second one, which was already mentioned also in our prior discussion, is hybridization. Diba? Yung mixing of 2 or more orbitals to form a new set of hybrid orbitals. Wherein for carbon, it can exhibit the following hybridization. And what are those? Diba? It may exhibit an sp hybridization, sp2 or sp3. So kailan siya sp3? Kailan sp3? Yung central carbon element kapag in tetrahedral orientation, yung central carbon, meaning it has 4 electron groups surrounding itself. Di ba kapag tetrahedral orientation, naka-sp3, hybridized yung central atom. Okay? Kailan naman siya nag-exist as sp2 hybridized? So kapag ang central atom is in trigonal planar, di ba? Kapag naka-trigonal planar orientation naman yung central atom, example carbon, it will now exist in sp2 hybridization. Okay? Or yung clue nyo lang dito is kapag ang carbon element will carry will have 1 double bond, it will carry 1 double bond, automatic that is in sp2 hybridization. Kapag ang carbon element puro single bonds surrounding itself, most probably that is in sp3 hybridized. Okay? Another thing, sp2 hybridization din siya kapag ang carbon atom, okay, carries 2. I mean, in sp naman, sp hybridization naman siya kapag it carries 1 triple bond. Okay? Naka-sp hybridized naman siya kapag it carries 1 triple bond. Okay? Kasi kapag 1 triple bond lang yung kinikarry ng carbon atom na yan, central atom ng carbon, meaning naka-linear siya, linear orientation. Okay? And we all know kapag linear orientation, yung hybridization that is related to linear orientation is sp hybridization. Diba? Linear man yan. Linear kapag Yung central atom, it only has two electron groups surrounding itself. Two electron groups surrounding itself. Yung isa, triple bond. Yung isa, single bond. And pwede din siya sp, okay? Pwede din siya sp hybridization if yung central carbon atom carries a total of two double bonds. Kasi naka-linear din yan. Diba? Linear orientation din to. Okay? Linear orientation din yung central atom na carbon dito. Okay, so kapag linear orientation ulit, sp, hybridization. Okay? Then the rest of this carbon, yung nasa kanan tsaka kaliwa, these are in trigonal planar orientation, yung mga carbon na to. So the same lang na siya. Diba? This carbon on the right and left side, same lang ani. Okay, so naka-trigonal orientation, ibig sabihin, sp2, hybridized yung mga carbon na nasa kaliwa at kanan. Okay, so again, I repeat, another property of carbon is hybridization. It exists in different hybridization. It could be in sp3 kapag lahat ng surrounding bonds, puro single bonds. Okay, again, lahat ng surrounding bonds for that carbon, puro single bonds, naka-sp3 hybridized siya. When a carbon carries one double bond, if it carries one double bond, okay, that is in sp2 hybridization. If a carbon, a central carbon atom carries one triple bond or a total of two double bonds, that is in sp hybridization. Okay? So this first two properties ng carbon mentioned, they were already discussed in our mga previous discussions nato sa org chem. Now, yung bago sa inyo is yung third one. Okay, yung third property, important properties of carbon is isomerism. Okay, yung isomerism, this is a phenomenon. Okay, ito yung existence of a compounds, no? Existence of compounds, may it be two or more compounds having the same formula. Okay, when we say the same formula, yung compounds existing, they have the same number, the same kind of atoms present in the molecule. Let's say, for example, this is the first molecule and then the second molecule, an X and a Y molecule. For both of the molecules, they have the same number of carbon. Let's say, for example, they have 5 total of carbon atoms and they have 10 total number of hydrogen atoms. Okay? So, same yung formula nila. Ito yung formula. Okay? General formula. Yan yung ibig sabihin ng formula, ha? They have the same number, the same kind of atoms present in the molecule, but they differ on the structure. Okay? They differ on the arrangement of the atoms. Okay? Magkaiba naman yung X, magkaiba yung Y. So, dun sila nagkakaiba sa structure. Okay? Ng mismong molecule. Again, when we say isomerism, that is a phenomenon, the existence of compounds having the same formula, the same yung number, the same yung kind of atom present in that molecule, but they differ on the structure. Okay, they differ on the arrangement. Paano yung 3D arrangement ng atoms? Okay, so dun sila nagkakaiba. Specifically, they differ on the arrangement of atoms based on spatial orientation, yung 3D arrangement, or they differ on the arrangement of atoms based on the order of bonding in the carbon skeleton. Okay? That is why, in general, we have two classification ng isomerism. General classification of isomerism. Again, we have two general classification of isomerism. Okay? Again, yung highlight sa isomerism, they differ in the structure. Okay? Okay. Now, they differ in the structure because of the una, pwedeng order of bonding, or based on the spatial orientation. Okay, so that makes it having two general classification. Now, when we say ang structures ng isomers differ in the order of bonding, we are referring to the structural. Okay, structural isomerism. Okay, again, whenever the compounds they differ in the structure due to the differences in the order of bonding sa mismong structure, we are referring to the structural isomers, structural isomerism. Now, kapag naman ang isomerism exists due to the differences in the spatial orientation of the atoms in that molecule, we are referring to the stereo isomerism. Okay, so these are again the two general classifications of isomerism, structural isomerism and stereo isomerism. Okay, so again do not forget, isomers, isomerism, yung main nyo lang na hint, same formula. Okay, same yung formula ng dalawa or tatlong compounds na yan, but kapag dinraw nyo yung structures nila, magkaiba. Okay, magkaiba yung structures. So this would be the flow of the topic outline that will be discussed for this afternoon session. Okay, so balik ko na to, isomerism, yan yung bigger umbrella. Okay, this talks about the existence of compounds, same formula, different structure. Under isomerism, we have two general classification. We have the structural isomerism. Ano yung sabi ko sa structural isomerism? They differ in structure due to the differences in the order of bonding. Kapag stereoisomerism naman, they differ on the structure because of the differences in the spatial orientation. Okay? Now, for today's session, we will discuss only, for today's session, we will discuss only these types of structural isomerism. Yung first three chain, positional, and functional, these are the major types of structural isomerism. Okay, so ito yung common yun ng mga primary types ng structural isomerism. Yung tautomerism, and ring chain isomerism, these are rarely existing mga isomers. But I will still discuss it with you. Although very limited lang niya siya sa mga specific molecules. But again, the most common na structural isomerism types are chain, positional, and functional. So ito yung aaralin natin for today. And the rest of the specific types under stereo isomerism, geometric, optical, conformational, this will be discussed for the following meetings. Okay, so let's begin discussing all about structural isomerism. Again, yung matatakol natin dito, puro structures na same ang formula but they differ in the structure because there is difference in the order of bonding. Okay, so let us start with chain isomerism. Okay, by the way, structural is also known as constitutional isomerism. They are just the same. Okay, sige, let's start with chain isomerism. So ano yung chain isomerism? Chain isomerism, this is very common among alkanes. Okay, ito yung clue nyo dito. Chain isomerism yan because puro alkanes yung given sa structures. Okay, so again, chain isomerism, this is common among alkanes. Sa alkanes lang ito, common because of the possibility of branching among alkanes. Okay? Pag sinabing there is a possibility of branching, ibig sabihin, yung carbon atoms, okay, they can be linked to the parent chain or to the main chain in different ways. Okay, so branching in alkanes. Okay, so again, common yung chain isomerism among alkanes due to the possibility of branching among alkanes. Okay, kaya nga tawag sa kanya chain isomerism. Nagkakaiba lang yung structure dahil sa differences in the branching. Paano nakalink yung carbon atom sa chain, sa main chain, okay, ng mismong alkane. Okay, sige. So for example, the given formula is C4H10. Now tell me, can you type in your answer? What do you think is this alkane? What straight chain alkane is C4H10? Very good, butane. Diba? It follows the general formula CnH2n plus 2. Diba? Yan yung general formula for alkanes, straight chain alkanes. So it follows, no? This formula, CnH2n plus 2. Kapag apat, you simply substitute. Kapag apat yung carbon, okay, C4, then substitute mo yung 4 dito sa may N. So 4 times 2, 8 plus 2, 10. Okay, so this is butane. So that is the first structure. This is the condensed formula of butane. Tama? CH3, CH2, CH2, CH3. Okay? And again, ito lang yun. Okay? Ito yung condensed structure. Ito yung formula. Meaning, sa structure na to, 4 yung carbon, 10 yung hydrogen. Okay? Now, I have mentioned before that butane has one isomer. Butane has one isomer, and that is the isobutane. Naalala? Okay. So, kung titingnan natin yung structure ng dalawa, okay, structure ng dalawang molecule, magkaiba. Diba? Ito, yung first structure, normal butane. Yung N dyan, that is normal butane, meaning yung carbon atoms are simply connected in a row, okay, in a straight row. So, normal butane. Whereas, on the second molecule, it also contains 4 carbons. Tama? 4 carbons yan. C, apat na carbon. Then, bilangin niyo yung hydrogen, di ba? That is still 10 carbon. So, the same yung formula ng dalawang molecule na to. But, they differ on the structure. Specifically, saan sila nagdi-differ? They differ on the branching. Okay? So, yan yung example ng chain isomerism. So, common siya among alkanes. Yan yung tandaan nyo basta chain isomerism. This only occurs among alkanes. Okay? Kasi nga, ang alkanes, they have that possibility of branching. Pwedeng yung carbon atom na to, yung carbon atom na yan, can be linked in different ways to the main chain. Yan yung chain isomerism. Okay? Another example, C5H12, type in your answer. What is this? A straight chain alkane. This is pentane. So, kung isusulat natin yung pentane, 5 carbon, okay, then you complete, di ba? 5 carbon skeleton, then you complete the formula via adding hydrogens. And that is a total of 12, di ba? Bilangin niyo yung hydrogen. Sa notes nyo, there are 12 hydrogens being shown in this first molecule, first structure. Now, na-mention ko din last time na merong isomers ang pentane. Diba? We have the isopentane and the neopentane. Okay, na-mention ko to yung mga common names ng mga isomers ng pentane. So that is isopentane, neopentane. By the way, I will not let you draw. Do not worry, I will not let you draw the isomers of the given formula. What I wanted you to learn here in today's discussion is for you to identify, to know uh, when it is a chain isomer, when it is a functional isomer, when it is a positional isomer. Dapat kabalo mo mag-identify. So, dili ko maghatag og exam o quizzes nga. Okay, draw the isomers of C6H14. No. I will give the structures. You will identify what type of isomerism exists, okay, in the given item. So, yun lang yung aaralin nyo for isomerism. Okay, you have to know how to identify the type, the specific type of isomerism. Okay, so again, for C5H12, diba, this is pentane, and pentane could have two possible isomers, the isopentane and neopentane. Bakit isomers sila? Okay, let's have isopentane first. Bilangin natin yung carbon in isopentane. 1, 2, 3, 4, 5. C5 din siya. And also, bilangin niyo yung hydrogen. 3, 6, 9 plus 30, di ba? 9, 10, 11, 12. So, H12 din siya. Same yung formula. Tama? Same yung formula. They only differ on the structure. Okay? Upon writing the structure, the arrangement of atoms, magkaiba. Specifically, magkaiba dahil sa order of bonding, 'di ba? And specifically, nagkakaiba. Bakit nagkakaiba yung order of bonding? Dahil sa differences sa branching, okay? In the main chain. Kaya chain isomerism yung type of isomerism na to. Okay, so another isomer ng C5H12 is neopentane. Ganon din, this is C5H12. Diba? Lima yung carbon, and there are 12, no? There are 12 hydrogens in this structure. Okay, so these are examples of chain isomerism. Again, common siya among alkenes. Okay, bakit lang sa alkenes? Kasi sa alkenes, they have that possibility of branching. Pwede natin i-branch, i-link ang carbon atoms in different ways sa mismong parent chain. Okay? So, yan. Next. Okay, let's have another example. Say, for example, C6H14. Okay? C6H14, so this is pentane. So, when we draw, skeletal lang akong i-draw ha para madali ta. Okay, when we draw the skeletal structure of hexane, it will have 1, 2, 3, 4, 5, 6. Okay? So, yan yung skeletal structure ng hexane or N-hexane. Okay? So, isa sa yung posible nga isomer is pwedeng a 5 carbon chain, then yung remaining carbon, dito ko ilagay. Let's try to check ha if this will still have 6 carbon, 14 hydrogen. Okay, so carbon first. 1, 2, 3, 4, 5, 6. So C6. Okay, what about the hydrogen? Itong highlighted with color black. Ito. Kaning mga black carbons, akong gi-highlight, they have, each of that will have 3 hydrogens, imaginary 3 hydrogens. Di ba mga terminal carbon sa alkanes, they will have 3 imaginary hydrogens for its skeletal structure. So 3, 6, 9 na yan, 9. Then for this, kaning green, for this carbon na siya imaginary nga, 1 hydrogen. So that's 10. Total of 10 na. Next, itong highlighted with the next, no? Carbon, this has 2 imaginary hydrogen. The same thing. Ito din, another 2 imaginary hydrogen. So total of 14. So H14 din siya. So this is an isomer of hexane. And marami pa. Okay, let me draw the other. So, pwede din Then you can have, instead nga dito mo ilagay yung branching, you can have it in the third carbon. Okay? Or pwede din, uh, 1, 2, 3, 4, apat lang yung parent chain, then the remaining 2 carbons, mga branch. Okay? Or pwede din, um, apat na carbon, but the branches is on the same carbon. So, check na to ha kung C6H12. Kanina lang ang last part. Okay? So, highlighted with orange, these are carbons. How many? 1, 2, 3, 4, 5, 6. So, C6. How many hydrogens? Check na to. Per terminal carbon, again, imaginary, 3 hydrogens. Per terminal carbon na siya imaginary, 3 hydrogens. So that is already 3, 6, 9, 12. 12 na siya. Plus, kaning last na ko gi-highlight with color black, na siya imaginary, 2 hydrogen, total of 14. Okay? So kung titingnan mo, lahat sila, the same formula, C6H14, C6H14, but they all differ in the structure. Particularly, nag-differ sila sa branching, di ba? Sa point of branching. Okay? Kasi yung carbon atom, pwede nato siya i-link sa parent chain, sa main chain in different ways. That is chain isomerism. Again, it only occurs among alkanes. Okay? So you can now name, so I will not write the names anymore of these alkanes. So you know already how to name alkanes. Okay? You know already how to name this alkane, what is this alkane. So in yung notes, i-name lang sila. I-name sila. And you will find out they will have different names. So pag different yung names ng structure, automatic they are different compounds, no? Hindi po ibig sabihin na kapag same yung formula, same na agad yung molecule. Okay? Knowing upon writing the structure, magkaiba yung structure, obviously they will have different physical chemical properties and they will be immediately a different structure. I mean different molecule, no? Different sila nga molecule. So ana. So that is all for chain isomerism. Okay, next, let us proceed to position isomerism. Okay, for position isomerism, take note, this occurs, okay, when compounds, take note, this occurs when compounds have different structure due to differences in the position of the functional group. Okay, yung kanina sa chain isomerism, nag-differ yung structure dahil sa point of branching in alkanes. This time, pag sinabing position isomerism, nagkakaiba yung structure because of the differences ng position of functional group. What are examples of functional group? Diba? Examples of functional group, we have double bond. Diba? Double bond, carbon to carbon double bond. What else? Alcohol. Yeah, kung maingon ka carbon to carbon double bond, that is alkene. That is a functional group of alkene. Another is alcohol. Another is halide. Diba? Pag may halogen, halide. And the rest of the functional group. Okay, so pag tiningnan mo sa structure, okay, magkaiba yung, nag-differ lang sila sa position ng double bond. That is position isomerism. Okay, so say for example, okay, the given molecular formula is C4H8. Sabi dito, it is an alkene with one double bond. So pwede ito, what do you expect kapag alkene nga carbons? Kapag alkene nga 4 carbons, that is, you can type in your answer. That is what? Kapag apat na carbon, ano yung prefix? Butene, tama. So you can have a butene here. And recall na kapag alkene, there is always, we always place a position for a double bond. Tama? Now for this first structure drawn, di ba? This is a butene, wherein ang double bond is present in what carbon? Present in carbon 1. Okay? So it is in between carbon 1 and 2. By the way, parehas lang yung structure na yan ha. Naka-calculate structure lang yung una. Yung pangalawa, naka-skeletal structure, but that is still, take note, that is still 1 butene. No, ano yung posibleng position isomer ng 1-butene? Sabi dito, different position of functional group. So simply move, no? Kapag ang double bond na nasa pangalawang carbon, this is carbon 1, this is carbon 2, okay? Nasa pangalawang carbon na yung double bond, magkaibang structure na yan. 'Di ba? This is not anymore 1-butene, but this is 2-butene. But if you try to count each number of atoms on these molecules, parehas lang sila, C4H8. Diba? C4H8. Bilangin mo yung hydrogens, 1, 2, 3, 4, 5, 6, 7, 8. Diba? And apat na carbon. C4H8 din yung pangalawang structure. The same formula, they only differ on this structure. Okay? Particularly, bakit nagkaiba yung structure nila? Because they have different positions of functional group. What functional group is being specified? Double bond, alkene. Okay, magkaiba yung position ng double bond. Okay, sa both alkenes na to. So this is an example of position isomerism ha. Ito yung tandaan nyo sa position isomerism. Dapat sa given nga item, parehas yung functional group na present. Hindi pwedeng position isomerism yan, ang isa double bond, ang isa triple bond. No. That cannot be a position isomerism. Dapat same functional group being presented in both or in among the molecules being presented in that item. So that is considered position isomerism. Nagkakaiba lang ba sa position dayon ng functional group? So another example for this formula C3H7 Br, this could be 1 bromopropane. Okay, so one structure niya could be 1 bromopropane, wherein again sa structure na to, ang bromo, okay, is present at carbon 1. Tama? Present at carbon 1. Pwede din yung structure for C3H7Br, yung bromine, yung bromo is present at carbon 2, making it 2-bromopropane. Diba? So magkaiba yung structure nila. But try to count, okay, and check the number and kind of atoms present in both structure. 3 pa din yung carbon, 7 yung hydrogen, 1 yung bromine. So these are isomers. Position. Isomers, nagkaiba lang sila sa position nasaan yung bromo. Okay? That is why we can also say nga ang position isomer, they could have different positions ng substituents. Okay? So pwede din substituents. Okay? So it occurs when functional groups or substituents are attached in different positions on a carbon chain. Okay? Now, pag sinabing yung binigay dito sa item 2, chlorine na. Okay? Yung isa, 1 bromopropane, ito naging chlorine. Tell me, do you think this still shows isomerism? Yes or no? You can type in your answer. No. Very good. So kapag pina-identify kayo what specific type of isomerism, make sure dili sa mo mag-identify diretso nga okay position ni siya, okay chain isomerism ni siya. No, you have to check first the formula. You have to count first if kani nga molecule tulo ba ka carbon, kanipod nga molecule tulo ba yang carbon. Okay? So dapat i-check sa ninyo siya, i-check sa ninyo ang structure kung parehas ra ang number of atoms and kind of atoms present in the structures being presented before din mo mag-identify sa specific type of isomerism. Before ka mo ingon nga change siya change siya position, etc. Okay? Kaya ayaw mo pailad nga okay na siya bromo, example ako ibalik ang bromo. Balik na ko ang bromo. Pero pag lantaw ninyo sa structure, ana na siya. Okay, ayaw mo diretso og conclude nga okay, position isomerism na siya. Because this time, the second molecule will now contains how many carbon? 1, 2, 3, 4. This is already C4 and not C3. Diba? Samot ang hydrogen, iba na yung number ng hydrogen. So that doesn't show isomerism. So make sure you check first the structure. So ihap-ihap raman ni, no? Kung kabalo ka mo ihap, kabalo ka maka-answer ani. Okay, for the isomerism. Then C5H12O, this could be an alcohol. Okay, wherein yung alcohol can have different positions on the carbon chain. Diba? Alcohol is a functional group. Do you agree? Diba? Functional group yung alcohol. Now, kung titingnan nyo sa structures being presented, sa first structure, nasa sa carbon 1. Sa second structure, nasa sa carbon 2. Sa third structure, nasa carbon 3 ang alcohol. So, nasa different position, okay, ang functional group ng alcohol. So, that is position isomerism. Okay, never mind first the names ng alcohol, how we have a separate segment in naming for the nomenclature ng alcohol. Okay, and the rest of the remaining functional groups. Okay, so next, this one. So position isomerism also commonly exists siya, or this commonly occurs among di-substituted benzenes. What do you mean by substituted benzene? Meaning, you have seen a benzene ring, okay na, ay benzene ring, then di-substituted na kay duha. Okay? Duha nga substituents attached to the benzene ring. So take note, position isomerism also commonly occurs among di-substituted benzenes. Kasi yung dalawang substituent na yan, pwedeng iba-iba yung positions in a benzene ring. But before we tackle the different position isomerism for benzene ring, let me teach you first how to name benzene. Madali lang yung pag-name ng mga benzene molecules. If you've seen a structure, kailangan tag benzene ring, di ba? A 6-membered ring, then ang inside ng ring pwede circle, kanya akong gidraw, or an alternating single bond, double bond, single bond, double bond. Yan yung benzene ring. So kung ang molecule na given has a benzene ring, then the parent chain, upon finding the parent chain, automatic ang parent is benzene. Okay? Diba ang first step in naming organic molecule is find the parent. So yung parent kapag benzene molecule, benzene. Okay, yan yung parent name. And what is the next step? Kapag nakuha mo na yung parent chain, you number, di ba? You number that chain. So you choose a point of attachment here. Now in this case, because the same lang naman yung substituents attached, di ba? So either lang imuhang carbon 1 and 2. Kaya parehas lang naman. Di ba? Parehas lang naman, chloro. So, mamili pa lugar ka nga, chloro raman na siya. But what if magkaiba yung substituent? So, inyo na lang dayong i-apply ang inyong knowledge on naming or choosing a point of attachment for a cyclic nga mga compounds. Let's say, for example, i-as is na to ang chloro, dito naging methyl. So, magkaiba na yung substituents attached to the benzene ring. So, that time, alphabetical priority Which do you think is carbon 1? The one with chloro or methyl? You can type in your answer. Okay, very good. So this would be your carbon 1, then tuyo ka, carbon 2, 3, 4, 5, 6. So ingana lang then, you can now name. Okay, very good. You can now name the benzene molecule. So this will be 1 chloro, 2 methyl. Then again, the parent is benzene. So ana lang. Okay? So you apply those knowledge you had sa naming ng molecules. Nalang gigamay nga changes because this is already in zine molecule, then the parent is benzene. So ganun lang din yung pag-name, what separates word and number, hyphen, what separates a number and a number, comma. Okay. Sige, balik tayo sa um, given nga structure. So for this structure, you can now name already no this benzene. So this becomes 1, sorry. So this becomes 1,2 dichlorobenzene. Okay lang ni small letter ha. Okay ra small letter ang letter D for dichloro. Okay, what about this structure? The name of this di-substituted benzene is 1 and 3. Okay, 1,3-dichlorobenzene. Okay, what about this structure ng di-substituted benzene? It is 1,4-dichlorobenzene. So that is how to name, okay, a benzene. Now, I wanted you to learn these prefixes that are commonly used in naming a di-substituted benzene. Kapag kasi di-substituted yung benzene ring, we don't usually use the 1, 2, 1, 3, 1, 4 nga mga positions. Okay, for the substituents attached to benzene. There are prefixes that are commonly used to identify the positions ng dalawang substituents attached to benzene. And these are, take note, ortho, meta, and para. Again, these are ortho, meta, and para. Ang ortho, this is written with small letter O, meta, small letter M, para, small letter P. Again, these are prefixes. So these are being added sa first part ng name of the molecule. So these are prefixes which indicates the position of the substituents in di-substituted benzene. Take note ha, in a di-substituted benzene only. Kapag tri, tetra, or penta-substituted na yung benzene, you cannot use this prefixes. Okay, only for di-substituted benzene. So, kailan pwede natin gamitin yung ortho? Take note, yung small letter O or ortho, this refers to two adjacent positions on a benzene ring. Ibig sabihin ng adjacent, kapag yung dalawang substituent magkatabi, that's the time you use the prefix ortho. Okay, so instead of 1, 2, di ba, magkatabi kapag 1, 2, magkatabi. Or 3, 4, magkatabi. Di ba? So kapag 1, 2, magkatabi, you can use the prefix ortho. So when you write the name of this molecule, this becomes O for ortho or ortho dichlorobenzene. Okay, so letter O, that is the symbol for ortho. O dichlorobenzene. So again ha, yung prefix na yan, that only indicates the position of the substituents na chloro. Yung dalawang chloro is in ortho position. Magkatabi sila. Nasa carbon 1 and 2. Next, meta. Meta position, that refers to the position separated by 1 carbon on a benzene ring. So, yung position ng dalawang substituent, 1 carbon apart. Okay, na space nga isa ka carbon ay hadayon ang next nga a substituent. That is why for the second structure, this can also be named as meta-dichlorobenzene. Again, the M meta kapag na 1 carbon apart sa duha ka substituent attached to a benzene ring. Okay, then para naman, para position, this refers to the position of substituent occupying the opposite ends, meaning parallel, opposite sa each other. Yung attachment ng dalawang substituent on a benzene ring, that's the time you use para prefix. Okay, so para dichloro benzene. Ma'am, can we use the prefixes if magkaiba yung substituent? Yes, yung kanina nga din Rocco, 'di ba? Ang isa chloro, ang isa methyl. Okay? Yes, you can still use that prefixes as long as di-substituted ang benzene. So this becomes, instead nga, di ba, 1, then chloro, di ba supposedly 1 chloro, and then 2 methyl benzene. So you will now use the prefix ortho, okay, ortho, then one word na dayon, you have chloro methyl benzene. Okay? Ortho position yung chloro tsaka methyl. Okay? Ortho position yung chloro tsaka methyl. Okay? Magkatabi. Okay? Now, balik tayo sa position isomerism. Okay? So, all these given structures, kaning disubstituted benzenes with a chloro substituent, lahat sila shows isomerism. Okay? Kasi same lang yung formula nila. Diba yung formula nila, lahat is C6, 6 yung carbon for a benzene ring. Diba? 6 yung carbon for a benzene ring. The hydrogen left here is only 4 na lang. Okay? So, 4 na lang kasi yung dalawang hydrogen has been replaced with 2 chlorine. Okay? So, C6H4Cl2, yan yung molecular formula. Molecular formula ng tatlong structure na yan being presented. So, they all have the same formula. But look at their structure. 'Di ba magkaiba yung structure nila kasi different yung positions ng substituents. Okay? Different yung position ng chloro, which is a substituent in a given benzene ring. So this is a position isomerism. That is why I mentioned earlier, common din yung position isomerism among di-substituted benzene. Okay. Now, kapag yung case dito, kapag ito pa rin yung tatlong structures are being presented, then ako siyang, ang isa ka structure akong i-replace, no? Sa isa ka structure akong i-replace ang isa ka substituent with the methyl. Do you think this still shows isomerism? Yes or no? You can type in your answer, no? Do you think? Yes. No, 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 it does not show isomerism this time. Okay, kasi magkaiba na yung number and kind of atoms present in one molecule. Okay, so that is how to identify isomerism. So again, for di-substituted benzene, common din yung position isomerism. I hope naintindihan yung ortho, meta, para. Okay? Usually, common gid ni siya, common ni ginagamit ng mga prefixes, ortho, meta, para, kapag yung dalawang substituents are the same. Okay? Kana gid pinaka-common nga application sa ortho, meta, para kapag ang dalawang substituents sa benzene the same. Puro methyl, puro ethyl, puro hydroxy, okay? Etc. Next. So we're done with position isomerism. Okay, let's have functional isomerism. Okay, so functional, from the word itself, no, from the term itself, functional, gikan sa term nga functional group. Okay, so this isomerism occurs when compounds, take note, when compounds have different functional groups. So take note this time, ang isomers being presented, ang structures being presented, they may have same formula, but yung structure nagkakaiba dahil magkaiba mismo yung functional group being shown. Okay? Ayaw mo ka libog sa position o sa functional isomerism ha. Kasi sa position isomerism, dapat the same functional group being presented. Parehas yung functional group, nagkakaiba lang sa position ng functional group. Kapag functional isomerism, yung isang molecule, iba yung functional group, and the other molecule, iba yung functional group being presented. Okay? So usually this occurs in pairs, but not all. But usually, but sa functional isomerism, they occurs in pairs. So say for example, the formula is C2H6O. This could have a structure of alcohol. Diba? This is alcohol kapag may OH. Okay, so that is one of the structure nga pwede nato ma-produce with this formula C2H6O. C2H6O, dalawa yung carbon, anim yung hydrogen, isang oxygen. Now, another structure that we can produce with this formula is an ether. Nadumduman ng ether, di ba? Ether is R-O-R. Alcohol is R-O-H. Magkaiba yung functional group kapag alcohol, iba yan sa ether. Okay, so this is an ether. Di ba? R is an alkyl group. Okay, any alkyl group. Okay? So kung titingnan natin yung structure, magkaiba. Saan sila nagkaiba? Magkaiba yung functional group present. No? Magkaiba yung functional group present. Yung isa alcohol, yung isa ether. But try to look at their general formula. Silang dalawa, they have the same number of carbon, they have the same number of hydrogen, and also oxygen. So they exist as isomers. Okay, isomers sila. So, yung sabi dito, they usually occurs in pairs. Yes, kapag ang given formula, you can produce an alcohol, automatic, it can also produce an ether. Okay, yan yung ibig sabihin ng they usually occurs in pair. Meaning, magka-pair ang alcohol tsaka ether. Okay? Sige, next. C3H6O. That formula can produce an aldehyde. Naala yung aldehyde, di ba? Aldehyde is a carbonyl carbon with a terminal hydrogen na ay carbonyl group, then a terminal hydrogen attached to the carbonyl carbon. So that is an aldehyde. And that general formula C3H6O can also produce another functional group in a form of, what is this? Carbonyl group with alkyl groups directly attached to the carbonyl carbon. Type in your answer. What is that functional group? What do you think is very good? That is ketone. Diba? So aldehyde is different from ketone. Okay? So different functional group, but they have the same general formula. Both of the structure have the same number of carbon, have the same number of hydrogen, the same nga isa lang yung oxygen. Okay, so this shows functional isomerism. So yun din, sabi ko, they occur in pairs. So yung aldehyde, kapag ang formula given can produce an aldehyde structure, automatic meron din siyang kaakibat nga ketone structure. So they usually occurs in pair. C3H6O2, pwede kang makapag-draw ng carboxylic acid structure here. Okay, for this given formula. C3H6O2, you can produce, you can draw a carboxylic acid structure here. Okay, so that is carboxylic acid. Tingnan mo yung structure, tatlo yung carbon, anim yung hydrogen, dalawa yung oxygen. Ito yung oxygen. Okay. Then another structure that it can produce is an ester. Diba? This is an ester, a carbonyl carbon with an OR. Okay, OR, an oxy attached to the carbonyl carbon. So that's an ester. So carboxylic acid is different from ester, different functional group. Okay, but the same yung formula nila. Diba? So this is a functional isomerism. So yan yung tandaan nyo for functional isomerism. Okay? So again ha, I will not let you draw the structure. I will not let you draw the isomers of a given formula. Okay? But instead, what you need to learn here is to know how to identify, to classify, to specify unsa nga isomerism being or existed in that given molecule. Okay, so kana lang inyuhang studyhan how to identify nga change sa position functional. Okay? Now, these are other examples, no? Other examples nga pwede dili mag-occur in pairs ang functional isomer. C4H8O, you can produce a ketone here. Okay? So this is a ketone. So sa inyong notes, naka muna mag-check ha kung apat ba talaga yung carbon, walo ba talaga yung hydrogen for that structure. But I assure you, this is the general formula for that given ketone structure. Okay? Now, another structure nga pwede nato ma-produce for this given nga formula is an alcohol with a double bond. Okay? So, that alcohol with a double bond. Diba? Sorry. Ayan. Diba? You have an alcohol and a double bond. Okay? Usually, ang specific group name ani is an enol. Bakit enol? Alcohol, ol, and in for alkene. There is a double bond present in an alcohol. Okay? Then, another structure pwede na ito ma-produce for this formula is an ether. Diba? This is an ether. R-O-R. Okay? That is an ether. An ether with a double bond. Okay? So, again, yung clue nyo lang in order to identify the existing isomerism is you first count, no? Count the number of each kind of atoms present in that structure. Bilangin nyo muna kung tama ba na parehas lang yung number of carbons, parehas lang ba yung number of hydrogen and oxygen and other atoms nga present sa kanilang tatlo. Okay, that makes it having or exists in isomerism. Okay, I had din ka mag-identify og specific type of isomers. Sige. Then C4H6, this also shows a functional isomerism. So, ayan. A butane, pwede ka makaproduce og butane here. 4 na carbon, 6 na hydrogen, or 1,3-butadiene. 4 pa rin yung carbon, 6 pa rin yung hydrogen. So, isomerism. Functional isomerism to be specific. Kasi, nagkakaiba yung structure because of the differences in the functional group. Ang isa, triple bond. Ang isa, alkyne. Ang isa, alkene. Diba? Magkaiba yung functional group. So, that is all about functional isomerism. Okay. Then for the remaining structural isomers, yung sabi ko kanina, di ba, gikan kay metamerism until ring chain isomerism, limited lang ni sila nga mga isomers, okay, existing. So specifically for metamerism, take note, this is limited to those molecules with a divalent atom oxygen or sulfur. Kasi for oxygen and sulfur, di ba yung most stable number of covalent bonds nila is 2. Kaya divalent atoms. Usually, they are being bonded to alkyl groups around it. Okay, that is why very common, take note nito, very common ang metamerism, limited lang ni siya among ethers and among thioethers. Thioethers are just the same with sulfides. Okay, so say for example, C4H10. Oh, so this would produce different ethers. Ethers kasi yung ethers, ROR, oxygen yung may oxygen na central atom. Kapag thioethers, it is sulfur dapat yung makikita sa general formula. So C4H10O, this will produce sets of ethers. Okay? So metamerism again, limited lang ni siya among ethers and thioethers. So example, so these are all ethers. So tingnan mo yung ethers. Different yung alkyl groups attached. Diba? Yung ether na to, dalawa yung ethyl. Okay, dalawa yung ethyl. For the second ether structure, isa methyl, yung isa propyl. For this ether naman, yung isang alkyl group surrounding it is a methyl. Yung isa is isopropyl. Okay, never mind the naming ha. Never mind the naming. Ato lang dire is, bakit siya metamerism? Okay, metamerism, it occurs among ethers. Okay, and, ayan, parehas lang na thio ethers. Gi-change lang ang oxygen into sulfur. Okay, so yun lang yung tandaan nyo, metamerism. Kapag sa items, okay, yun yung nabantayan, puro man siya ethers and they show isomerism. Then the best answer for that is metamerism. Although, somehow, pwede diba siya position isomerism. Pero kapag pina-identify mo din na as a choices, metamerism, the best answer would be metamerism. Kasi somehow, yung mahuna-una, pwede man siya position isomerism. Kasi same yung functional group, nagkakaiba lang yung structure sa position ng functional group, and that is position isomerism, diba? Okay, but again, the best answer or correct answer for this, kung specific good nga isomerism ang gipangayo, it's metamerism. Then for tautomerism, another rare, no, rare lang ni siya nga isomerism. This, ito lang yung tandaan nyo, this occurs among ketone and enol group. Yan lang. So, kaila man tag ketone, no? Kaila tag ketone. R, di ba? RCR. Yan yung ketone. So, kung makakita kag ketone, ang iyahang kasama sa item is an enol, alcohol with a double bond. Check ninyo, parehas sila og formula, parehas og number ng carbon, hydrogen, or oxygen. Parehas, so it shows isomerism. Ang specific type of isomerism for that is tautomerism. Again, this is specific to ketone and enol. Ketone and enol to ketone. Okay, so yan yung sabi ko kanina, ang metamerism, tautomerism, and ring chain, limited lang siya sa mga specific molecules. And lastly, ring chain isomerism. Ring chain isomerism naman, from the term itself, ring, meaning a cyclic molecule, and a chain molecule, meaning an open chain molecule. So, pair up na siya. Okay, naa kay open chain molecule that shows isomerism with a cyclic molecule. So, naamoy idea ani, knowing nga I have introduced to you, diba, the general formula. Naalala niyo yung general formula ng cycloalkanes and alkenes, they have the same general formula that makes them isomers to each other. An alkene is an open chain, diba? An alkene is an open chain molecule. Cycloalkanes is a cyclic molecule, so they have the same general formula, CnH2n. The same with alkynes, to that of cycloalkenes. Diba? The same yung general formula nila, CnH2n minus 2. That is why they are isomers to each other. Alkynes, an open chain. Cycloalkenes, a cyclic molecule. So, pair ni sila, pair. Okay? So, say for example, the given formula is C3H6. You tell me what is the possible hydrocarbons nga pwede nato ma-draw into structure for this formula. Is it alkenes, cycloalkenes, or alkynes, cycloalkenes? You can type in your answer, no? C3H6, given this general formula. Okay, very good. It is alkenes, cycloalkanes. Di ba? Given naman C3. So kung 3, inyong i-substitute dire. Di ba? H2 times 3. Di ba? Kapag ang carbon daw tatlo, so kung imo i-substitute na 3. So 3 times 6, C3H6 yung magiging resulta for its formula. So most probably, you will produce an alkenes and a cycloalkene. So that alkene is a propene. Di ba kapag tatlo yung carbon, tama ba? Kapag tatlo yung carbon, propene. Okay? Kapag tatlo yung carbon sa cycloalkane, how do you name that? Tatlo yung carbon sa cycloalkane, cyclopropane. Okay? Now try to check the formula. Try to check the formula of the both structure the same. Tatlo yung carbon, anim yung hydrogen. 'Di ba? Tatlo yung carbon, anim yung hydrogen. So the same with C6H12, this also will produce alkene, a hexene, and a cyclohexane. Cyclohexane. Take note ha. Take note sa partner, sa pairing. It is alkene and cycloalkanes. Not cycloalkenes. Kasi yung partner ng cycloalkenes is alkyne. Sila yung magkapareha yung general formula. CnH2n minus 2. Then C5H8. So ito yung sample for alkyne cycloalkene. So C5H8, C5, 5 pentine. Okay, you will produce a pentine for an open chain molecule. And for its cyclic molecule, you will produce a cyclopentene. Okay, cyclopentene. So it is already your responsibility to count, no? To count kung tama ba nga 5 yung carbon for both this molecule. And kung 8 ba talaga yung hydrogen for these molecules. Okay, I assure you, this both structures will have the same formula C5H8. Okay, so that would be all for today's session. Okay, we're done. So kindly answer this. Kindly answer this 1, 2, 3, 4. Then i-assignment na lang nako ni siya, no? Assignment, maghatag lang ko og Google form. Magbuhat ko after this lecture session. Magbuhat ko og Google form, dito ra ninyo i-type in inyong answer for this assignment. 1, 2, 3, 4, magdugang lang ko isa para 5. Okay, 2 points each. You simply identify the type of structural isomerism. If it is chain, position, functional, tautomerism, metamerism, or ring chain isomerism. Okay, just follow the instruction being provided. So Google form lang siya para diretso ra din ninyo makuha inyong scores. Okay? Sige. So that would be all for this morning. Do you have any questions?
None so far po.